Hi everyone. In the last class is discussion about the concepts of physical quantity. What is the definition of physical quantity? What is the types of physical quantity? That is, the physical quantity means the any measurable quantity is called physical quantity. The physical quantity is classified into two different types. One is the fundamental quantity. The one more is derived quantity. That is, the fundamental quantity means the meaning of it is also physical quantity. It is independently derived quantities is called fundamental quantities. Example, there is total the 7 fundamental quantities is there. First one is mass, length, current, and luminous intensity, temperature, and that is the what is called fundamental quantities. The total 7 fundamental quantities. These are the examples of fundamental quantity. And the second type is derived quantity. Derived quantity. That is, derived quantity means it is also physical quantity. The derived quantity is also called, it is also physical quantity. It is derived from the all by using a fundamental quantities of all physical quantities is called derived quantity. The derived quantity is also physical quantity. It is also physical quantity. It is derived from the all the physical and fundamental quantities. Fundamental quantities is called what? That is a derived quantity. What is the examples of derived quantity? There are so many derived quantities is there. That is the examples is area, volume, and distance, displacement, frequency, pressure, force, work done, torque, moment of force. These are the examples of derived quantities. That is the second type of physical quantity. That is, the second type is it is called derived quantity. Derived quantity means it is derived from the all fundamental quantities is called derived quantity. First one is there are so many derived quantities is there. First one is the list of the next list of the derived quantities. List of derived quantities. Derived quantities. First of all, first one area. That is, the common symbol is the area symbol is that is capital A, and area, what is the SI in it? That is the first column is it is represented by physical quantity, and second column is it is represented by symbol of the physical quantity, symbol, and the third column can be represented by, that is what is the SI in it? The SI in it, the CGS system. In the previous class, that is talking about, there is a concept of system of units. There are 4 different types of what that is SI systems. First one is the FS system. Second one is CGS system. Third one is that is a MKS system. Fourth one is called SI system. The FES, foot, phone, second. Foot, the length in foot, mass in phone, time in second. It is the FES system can be derived from the length in foot, mass in phone, time in second. That is called what? That is the FES system. And the second type is the CGS system. CGS, centimeter, gram, and second. S means second. The length in centimeter, the mass in gram, time in second. That is the expand of the CGS system. Next, third one is MKS system. MKS means there is a total, there is a length in that is first MK meters. The unit of length is meters, and the unit of mass is kg, kilogram. Kg means kilogram. The time in second. The unit of time in second. It is expansion of the MKS system. And SI unit means it is a commonly used in my world. That is MKS and SI systems. It is an international system or universal system. The SI system is it is a universal system and international system. That is called, that is a fourth type is called, that is the SI system. It is commonly used in our life. That is what is the first area? The first derived quantity is area. The area is defined as it is a length into breadth. length into breadth. That is represented by symbol is capital A. Capital A is the symbol of area. What is the unit of length and breadth in SI systems? The length, that is the length means that is the distance. Breadth means that is the length in meter. The breadth in meter. Length meter into meter, that is called meter square. The unit of area is meter square. And the second derived quantity is volume. Volume. That is volume means example. The better example is the beaker containing liquid. The any liquid. That means how to measure the volume of the liquid. That is the volume definition is what is the length of the liquid, what is the breadth of the liquid, what is the height of the liquid. What is the length, what is the breadth, what is the height. The unit of length is meter, the unit of breadth is meter, the height of the unit of the height is meter. Meter into meter into meter, that is a meter cube. The unit of the volume is the SI unit of volume is meter cube. That is it is represented by symbol is capital V. The capital V is it is the symbol of the volume. That is the second derived quantity. Next one is density. Density. That is the symbol is sig rho. This symbol not P. That is a rho, bending shape. And density. The density is defined as mass by volume. Mass by volume. The ratios of the mass by volume, that is called density. What is the mass of the liquid? Now, first of all, what is the density of water? The density of water is that is 1,000. 1 kg per meter cube. That is a constant value. What is the mass of the water? What is the volume of the water? That is called density. The density is defined as the mass per unit volume is called density. What is the SI unit of density? The SI unit of mass by volume. The unit of a mass. The SI unit of a mass is kg by the unit of a volume is, that is already find out. That is m cube. That is m cube. That is kg for meter cube or kg meter inverse cube. Kg for meter cube or kg meter inverse cube. That is the SI unit of density. Next, the fourth one is displacement. Displacement. It is also displacement also. It is a vector quantity. Density and volume area, that also vector quantities. Vector quantity means it is a particular direction and magnitude. In presence of direction and magnitude is called vector quantity. That is the fourth one is the fourth physical quantity is derived quantity is displacement. Displacement. Now this symbol is that is represented by S, capital S. Displacement means it is that distance. The displacement means that is the symbol is S. The displacement or distance. Distance. What is the difference between distance and displacement? Distance means it is the position of the object is changes at particular direction, that is called displacement. Particular direction. The direction of the particle is any one direction, that is called displacement. Example, what is the example? Clock. What is the direction of the clock? It is a clockwise or anti-clockwise? Clock direction. That is called displacement. The particular direction of the object is called displacement. Distance means it is any direction of the particle. The position of the particle is changes with any direction, with any direction is called distance. The fourth one is displacement. The symbol is S. It is the unit of distance in meter. The SI unit of a displacement is meter. Next to the fifth quantity, fifth derived quantity. The fifth one is velocity. It is a symbol is represented by V. Small v or capital V, both are same. Small v or capital V. That is the velocity is defined as, what is the first of all meaning of the velocity? The velocity is defined as the rate of change of displacement. Velocity is a vector quantity. The velocity is a vector quantity. The displacement also vector quantity. Vector quantity, it is represented by particular direction and magnitude. That is called velocity. The rate of change of, that is called vector quantity. The meaning of the velocity is called the rate of change of. That means V is equal to S by T. Rate of change of displacement is called what? Velocity. The unit of a, what is the unit of distance? The distance in, this is unit of SI unit of distance in meter. The unit of time in second, meter per second. The SI unit of a, the SI unit of a velocity is meter per second or meter second inverse. That is the one of the derived quantity. Next, the sixth quantity is, the sixth one, the sixth derived quantity is acceleration. Acceleration. Acceleration, that is the symbol is represented by small a. The acceleration means it is also vector quantity. It depends on the velocity. The acceleration is defined as the rate of change of velocity. The ratios of velocity by time is called what? Acceleration. That is called acceleration. The symbol is a. The unit of, first what is the SI unit of acceleration? The SI unit of a acceleration is the unit of velocity. First find out the unit of a velocity, meter per second divided by the unit of time is second. The unit of a time is second, or meter per second square, or meter second inverse square. Or the SI unit of a acceleration is meter per second square. Meter per second square. Next, the seventh one is, the seventh derived quantity is force. Force. What is the example of force? It is, the symbol is capital F. The pushing of any object. It is a better example of the force. That means the force. What is the mass of the object? What is the speed of the object? That is called force. That is the force means, that is a F is equal to, the force equation is mass into acceleration. The force equation is mass into, the force equation is mass into acceleration. Mass into acceleration. The mass, the unit of a mass is, it is a mass is a fundamental quantity. The standard unit is, that is the CGS, or sorry, the SI unit of a mass is kg. What is the unit of acceleration? That is meter per second square. That is or kg meter second inverse square. The totally the SI unit of a force is, the standard unit is, it is Newton. That is the symbol is capital N, Newton. The unit of a, the SI unit of a force is Newton, or one more SI unit is, that is kg meter second inverse square. Kg meter second inverse square. That is the SI unit of force. Next, the eighth one, the eighth derived quantity, that is the work done, or work. It is, the symbol is represented by capital W. Capital W is the symbol of work done. The work done is, it is also the work done, the pushing of, that is also similar to force. That is force into, that is displacement. When applying the external forces, the object is moving certain distance. That is called distance. The distance in meter. The unit of force is Newton. That is the definition of work done. There are so many types of work done. Two types of work done. One is positive and negative. It is the higher education. That is the concept. That is of only what is the, in this concept is, that is what is the derived quantities. The work done is defined as the product of force into displacement. That is called the pushing of a door. That is called work done. That is a better example. Force into displacement. The unit of force is, the unit of a force is Newton. The unit of a distance is meter. That is the unit of a, that is work done is Newton meter. Newton meter or Newton meter inverse. The standard SI unit of a work done is joule. S-O-U-L. Joule. L-E. Joule. That is the symbol is capital J. Capital J is the, that is the joule. The SI unit of a work done is joule. That is the eighth physical derived quantity. Next one is, ninth one is energy. Energy. It is, what is the meaning of energy? It is also, energy also similar to work done. It is, the symbol is, it is represented by E or capital U in alphabet. The energy can be represented by, the symbol is capital E and capital U. That is, the SI unit of energy is joule. Same, similar word. Joule, capital J. And the meaning of the energy is, it is capacity to do the work done. in presence of work, the unit of work done is Newton meter or joule or Newton meter inverse square inverse Newton meter inverse. The energy means it is capacity to do the work done, that is called energy. It is represented by symbol is E and capital U, capital E or capital U. The unit of energy is joule. Next one, the 10th one is power. The power, POW, power. It is a power. It is represented by symbol is the P. P is the symbol of power. It is a SI. The standard SI unit of a power is watt. WATT, watt. W. That is a capital W. Capital W is the symbol of the watt. That is, the power is defined as, the power is defined as the product of force into velocity. The product of force into velocity, that is called power. The power means it is a symbol of the power is capital P. The SI unit of a power is watt. The one more SI unit of a power is, the unit of force is Newton. It is a V is the velocity. The unit of velocity is meter per second. The one more SI unit is, it is Newton meter second inverse. Newton meter second inverse. That is the SI unit of power. The SI unit of power is watt. That is the standard SI unit. The power is defined as the force into velocity is called what? Power. Next, the 11th one. The 11th physical or derived quantity is linear momentum. Linear momentum. Linear momentum. It is a symbol is, it is a linear momentum can be represented by small p. Small p. What is the SI in it? The linear momentum is defined as the product of mass into velocity. The product of mass into velocity, that is called linear momentum. The linear momentum is defined as the mass into velocity is called linear momentum. It is any translational motion. Linear momentum is it is a translational motion. The moving of any object. That is also, it means product of mass into velocity. The unit of the linear momentum. What is the SI unit of linear momentum? The unit of a mass is kg. The unit of velocity is meter per second. The SI unit of the linear momentum is kg meter per second. The SI unit of, or the SI unit of a linear momentum is kg per second. Kg meter per second or kg meter second inverse. That is the one of the what derived quantity. The linear momentum is it is a translational motion. And the 12th one is angular velocity. Angular velocity. Angular velocity. It is a angular velocity means it is a rotational motion. The rotational motion means the any particle is moves circular path. The angular velocity means the any particle it moves circular direction is called, that is a rotational motion. The angular velocity is also what? That is the angular velocity is also rotational motion. It is represented by symbol is omega. Omega. The symbol of the angular velocity is omega. The SI unit of the standard, the SI unit of angular velocity is radian second inverse. It is the distance. The velocity means the rate of change of displacement. The unit of a in the unit of a, it is a translational motion. The angular, the linear velocity or velocity, it is a translational motion. Translational motion means the particle is moves linearly or uniformly. That is called translational motion. That is the unit of the average velocity is, that is a meter second inverse. The angular velocity means the particle is moves rotational motion. That means it is an angle. The angle is converted to radian. That is the unit, the distance it is measured in radian. The unit of time in second inverse. Radian second inverse. That is the one of the derived quantity. And the 13th one is, that is angular acceleration. Angular acceleration. Angular acceleration. That is, the symbol is alpha. The symbol of the angular acceleration is alpha. First of all, what is the meaning of angular acceleration? The angular acceleration is also rotational motion. It is also called rotational motion. It is a symbol is alpha. What is the SI unit of angular acceleration? It is angular acceleration is a rotational motion. What is the definition of angular acceleration? That is, the angular acceleration is the rate of change of angular velocity. The rate of change of angular velocity. That means alpha is equal to omega by t. That is the formula. Alpha is equal to omega by t. The unit of angular velocity means that is the radian second inverse. And time is second. Second inverse square. That is the angular acceleration. The SI unit of a angular acceleration is radian second inverse square. Radian second inverse square. That is the one of the type of derived quantity. And the next one, the 14th one, angular momentum. Angular momentum. The physical quantity is angular momentum. That is, the symbol is momentum. The symbol is, that is the L. Angular momentum. It is represented by symbol is L. What is the SI unit of angular momentum? The angular momentum means it is a SI unit of the angular momentum is, it is a kg meter square second inverse. Kg meter square second inverse. That means the product of what? The product of, that is the kg, the unit of a mass is kg, the unit of area meter square, that is mass into area divided by time. That is called angular momentum. The angular momentum is it is also rotational motion. It is represented by the product of mass and area and the inversely proportional to time. That is called angular momentum. The symbol of it is represented denoted by angular momentum is small l. The SI unit of mass is kg. The SI unit of area is meter square. The unit of time is second inverse. That is the SI unit of angular momentum. Next, the 15th one, the moment of inertia. Moment of inertia. That is also rotational motion. The symbol of the moment of inertia is capital I. The moment of inertia is defined as, that is the mass into the product of mass. The moment of inertia I is equal to the square of distance between them. Any two particles, that is particle A and particle B. The particle A and particle B. The distance between the one particle to another particle is taken as A. That means according to the rotational motion, the moment of inertia, the square of a distance between them. What is the mass of the each particle? What is the mass of the first particle? What is the mass of the second particle? That means the product of mass and the square of distance between the any two particles, that is called moment of inertia. It is represented by symbol is capital I. The symbol is the moment of inertia is capital I. What is the unit of mass? That is the kg. The unit of mass is kg. The unit of distance, A is the distance. That is a small d. That is small d or small a, both are same. That is represented by symbol. The unit of distance is meter. Kg meter. That is the one of the unit of meter square. The area square is there. That is one a square can be written as a into a. The a square can be written as a into a. The one of the unit of acceleration, area, that is meter. The unit of distance is meter. Meter into meter, that is meter square. Kg meter square. That is the one of the derived quantity. The derived quantity, the physical moment of inertia is a rotational motion. What is the meaning of moment of inertia? The product of mass and the square of distance between the any two particles, that is called moment of inertia. That is represented by symbol is capital I. The SI unit of a moment of inertia is kg meter square. Kg meter square. Next, the 16th one is torque. Torque, T-O-R-G-U-E. Torque or couple, both are same. A moment of force, both are same. Torque, couple, and moment of force. The torque is also rotational motion. It is a symbol is tau, T-O-W, tau. That is not T. Tau is the symbol of torque. And what is the SI unit of torque? The torque is defined as, the meaning of torque is tau is equal to force into distance. Force into distance. The force, the unit of force is Newton. The unit of distance is meter. That is the standard unit is Newton meter. The torque is the force into displacement is called torque. The torque is it is a rotational motion, that is called torque. It is represented by symbol is tau. The SI unit of that is torque is Newton meter. That is one of the physical quantity. Then next one is 17th one, period or time period. Time period. This is a symbol is it is commonly used in daily life. It is a time, capital T. It is a time in. It is a unit of in. It is measured in time in seconds or hours or minutes. It is commonly used in seconds. S is the unit of time period. The unit of time period is second. The time period, the meaning of time is, that is the time taken by complete one circle is called time period. The time period means the time taken by complete one oscillation is called one circle, one vibration, that is called time period. Next, 18th one is frequency. Frequency, that is represented by symbol is F or small n. Some textbooks it is denoted by the frequency symbol is small n. Some textbooks is F. The symbol is, the frequency means, see, the frequency, the one oscillation, the time taken by one circle is called time period. That is the one oscillation, the frequency means the number of cycles or vibrations or oscillations made in 1 second. The number of vibrations, circles or oscillations are made in 1 second is called frequency. It is a formula is F is equal to reciprocal of time period. The F is equal to reciprocal of a time period. The unit of a time is, that is a second inverse. That is also SI unit. Second inverse or Hertz. Standard SI unit is Hertz. The SI unit of a frequency is Hertz. It is represented by symbol is F and small n. Or the definition of the frequency is the number of vibrations made in 1 second. That is called frequency. That is a frequency also. That is one of the derived quantity. Next, 19th one is gravitational constant. Gravitational constant. Gravitational constant. That is the symbol is capital G. The symbol of the gravitational constant is G. How to define gravitational constant? The gravitational constant is the force. Gravitation, F is the gravitational force. F is called gravitational force. The gravitational force is directly proportional to area, and the gravitational force is, it is inversely proportional to masses, product of inversely proportional to masses, that is called M1 and M2. Combining these two equations and area and masses, that is F is proportional to area and M1 into M2, or F is when you remove the proportionality, that is the G is a constant, that is called gravitational constant. Gravitational constant. F is equal to G A by M1 M2. Find the value of G value, or G is equal to F into M1 M2 by divided by the A. This is the gravitational constant equation. G is equal to F into M1 M2 by area. The unit of force is Newton. The unit of masses is, unit of M1 mass is kg, M2 mass is kg, kg into kg square. For the unit of area is meter square. That is Newton meter square kg inverse square. One more definition is that is, or it is the F is directly proportional to R. See, the F is directly proportional to product of masses, the F is inversely proportional to area. Find out this one. That is, the F is proportional, combining these two equations, that is m1 m2 divided by area. When you remove the proportionality, that is called, the G is called proportionality constant, G into m1 m2 by, that is area. Find the value of G value, therefore G is equal to, find the value G, that is F into area divided by mass 1 mass 2. What is the unit of force? That is the Newton. The unit of area is meter square. For the unit of masses is mass kg into kg square. That is the SI unit. Therefore, the gravitational constant is, it is the gravitational force is, first listen, the gravitational force is defined as, the gravitational force is directly proportional to product of masses. The gravitational force is inversely proportional to area. Area, that is called gravitational constant. The gravitational constant is, it is the symbol is G. The SI unit of a gravitational constant is, that is Newton meter square per kg square, or Newton meter square kg inverse square. That is also one of the derived quantity. Next